Hey guys, hi everyone, hello. So, today we'll be seeing complex numbers. So, hello guys. Yes, can you hear me properly? Hello. So, yes. So, today we'll be starting complex numbers. So, chapter 4 is quadratic equations and complex numbers. So, till 10th, you wouldn't have known, right? So, till 10th, you will have a confusion. What confusion is that? Like, what is a complex number? Like, from 10th, there's a transition, right? From 10th to 11th, right? So, there is a transition in that like in 11th they would have told you when negative root, when negative numbers comes inside root, you should not consider it, right? In 10th they would have taught like that, right? But here complex number is based on this concept. So before going into this concept, you'll have something in mind, right? What should you learn? Like, why should you learn complex numbers? What is an extension of complex numbers? Like, what is exactly a complex numbers? So what, why, and yeah, how should you learn? Yeah, basically that. And before going into the session, see, in engineering, definitely if you take engineering or something related to like mathematics, definitely you'll be having complex numbers. So you should understand the ideology behind it before jumping into the complex numbers. So first, we know what is a quadratic equation, right? So we all know what is a quadratic equation. So generally, what is a quadratic equation? So yes, what is a quadratic equation? So yes. So okay, let me tell you. So now if you have like generally a quadratic equation is nothing but you should have the x power should be 2. Then only what do you say with like what do you say? How do you define a quadratic equation? So any polynomial of degree 2, highest degree should be 2. That is not nothing but that is a quadratic equation. So you have learned methods in 10th standard, right? 10th standard, like you have learned how to solve a quadratic equation, right? So basically what is the formula behind solving the quadratic equation? So the formula behind solving the quadratic equation is minus b plus or minus root of b square minus 4ac by 2a. So this is the equation for solving a quadratic equation, right? So like when you solve this, you'll get the roots. Basically, you'll get the zeros. You can say it zeros, roots, anything, right? So basically, you'll get the roots of a quadratic equation when you solve it. Okay, so you'll be thinking, why are we talking about quadratic equation in complex numbers, right? So I will gradually tell you how complex number came into the world. Like, let me tell you that. So you will have, this is the basically this is the formula, and it is written as like basically ax square plus bx plus c. So this is the this is the quadratic equation. Now what should you do? Now you have a here and this is your b here, and a is the coefficient of x square and b is the coefficient of x and c is the constant. Okay, so this is the quadratic equation. For example, if you get something, if you get as root of 9, what will it be? It is root of 9 is nothing but, after solving these, inside this root, basically inside this root, if you get root 9, what will be your answer? If you get root 9, that is nothing but 3 square, so 3. So it is again a real number, so no problem. Suppose if you get root 8, okay, it is not a square root number, it is not a squares of number, okay. But how can you how can you solve it? You can solve it by what the method, right? The long division method which you used to solve, which you used to find square root. So you will get an answer in what? Some real number, some point number you will get. But for example, like for in this case here, if you get something in negative, for example, if you get 3, when you were young, like when you studied 10th standard, they would have told you, no, that's wrong. But like that can't happen, right? They would have told you that can't happen, yeah, right? But here, this is how complex number arrived. How did complex number arrive? Nothing but inside the square root, if you have some negative number, then what do you say with it? So inside the square root, if you have some negative number, what is it? You will get, what will you get? You will get a complex number. So basically, in your 10th standard or 9th standard or some of your lower classes, they would have told that there should not be negative numbers inside the square root. So in this case, if you have a negative number inside the square root, where will it go? It will be a complex number. This is how complex number came into the real world. Okay. So, did you guys understand it? So, yes, did you guys understand it? So, yes. Okay. So, now let's see. Okay. Now we saw how did complex number arrive. So, basically, complex number, basically a quadratic equation into a complex number. Basically, how did a complex number arrive from a quadratic equation? That is our like intro. Basically, this is how complex number came from the quadratic equation. So before going into what is a complex number and what is a for the properties of complex number, let's quickly in this session we'll be mainly dealing with concept of complex number alone and the sums. So before knowing the complex number, you should know an important thing, which is nothing but imaginary number. Okay, so this is a important thing which you should know when it comes to a complex number. So when someone asks, what is a complex number, or can you tell some terms related to complex number? Definitely you should tell the imaginary number. And imaginary number, you should have a name for imaginary number, right? That is called iota. So I is represent, like I is nothing but iota. How do you call it as? You should call it as iota. So basically that is called as imaginary number, which is the main integral part of our complex numbers. So this is our intro. This is how our complex number arrived into the system of world, and then comes then inside it comes the iota. So I hope you guys like understood it. Okay, now let's see. So before going into the iota, the imaginary number, let me give you a example, like, no, not an example, a quick fact. Till 10th standard, what would have they told you? They would have told you that real number is the biggest number. You have natural number, it will be inside the real number. You have an integer, it will be inside the real number. You have a whole number, it will again be inside the real number. But when this person arrived, what is this person? This complex number arrived. It just defeated everyone and it became the whole universe. So basically, your universe is your complex number. Inside that only you will be having the real number. Then only after that, as usual, you know, right? Inside real number, you will have your natural numbers, whole numbers, integers. So basically, your big universe, or you can call it as universe itself. So basically, if you call the whole number system as universe, that will be a complex number, and in universe our earth will be our real number, and inside that if you have India, like India will be our whole numbers, and in like integers, basically integers also. Okay, in India will be our integers, and in any specific states will be our whole numbers, and inside that only, inside that specific city will be our natural number. So till 10th, you would have learned that real number is the biggest, is the superset of all the numbers. But there is a number bigger than the real number, that is our complex number. So basically, this is your complex number, and here comes the real number. So basically, this is your complex number, and here inside that, what will it be? Here inside it comes our real number, and yeah, then comes our natural number or something. Inside that, you can have many things. Okay. So what can you conclude? Complex number is the superset of real number. So is it good, right? Like you have a drastic change. In till 10th, they would have told you that they would have given you different assumptions. But suddenly when you come to 11th, no, they are telling that no, these are just assumptions. You have few more things to learn, and they suddenly introduce complex number to you. So that is how like this is the brief description about the complex number and introduction of it. So if you guys understood, just quickly give me a thumbs up. Yes. So okay, so now let's go to the next one. So what, as I already told you about the imaginary number. What is imaginary number? So imaginary number is nothing but, it is defined as the square root of negative numbers where it does not have a definite value. So basically, it is square root of some negative number, and that negative number does not have any value. So this is very important. And how do you call this as? You can call this as iota. You can call this as iota. I is nothing but, and how do they represent it? They represent it as I, and this is called as iota. Okay, so and they represent it as I. Okay, and see, mostly it is written as I. And if something is given, if some undefined value, not defined value is given, it should be something, right? Basically, what did I tell? It is root of some negative numbers. You know what is 9, you know what value does 9 have. But root of negative number, how can you write this minus 9 as? So basically, how can you write this minus 9? You can write this minus 9 as minus 1 into 9, right? So you know what is 9. 9 is a real number, right? And you don't know what is root of minus 1, right? So here the root of minus 1 is our game changer. That is our imaginary number. Okay. So basically this root of minus 1 is our imaginary number. So root of minus 1 is equal to I. So your imaginary number or your iotas value is root of minus 1. Okay, that will be our iotas. Like you don't have a definite value, but you can assume it as, like not assume, you can definitely say it as root of minus 1, but that value you won't be able to find, right? So root of minus 1 is defined as iota. Okay, that is our, like you should definitely remember this, because throughout your entire complex number, you will be solving it. Okay. Now, okay, we learned about iota. Okay. Is there some power of iota? Can you find, like, is there some, what happens if they give you, they generally give you, right? They generally give you powers of some numbers. So basically, they can give you root 3 the whole square. You will be able to find. What about the powers of iota? Is there, like, any values will have powers? So same way, if you think about that, will you have a power for iota? Like, do you have any idea regarding it? Quickly comment if you have any idea regarding it. Like, do you have a power of iota? Yeah, like you'll be thinking, right? You'll be confused actually. So there is a power of iota. So before going to this power of iota, now just learn about what is a complex number. So powers of iota, I will be shortly telling you in the next in the after the slide. So now what is a complex number? So complex number is basically a combination of, basically it contains a real number as well as a imaginary number, right? So they are telling that it is a combination of real number and imaginary number. That is called complex number. So how do you represent it? Can you see this? So here you represent a complex number as Z. Z is equal to A plus IB. A is nothing but a real number. You know what is I? I is an imaginary number. So IB is basically what? So IB is basically imaginary part, right? So if for this, I will give you a few examples for imaginary numbers. So it will be very clear for you before you go to the complex number. So examples, for example, you can have 3i. 3i is an imaginary number. Then you can have 4i or minus 5i, anything. These are the examples of the imaginary number. And iota is a Greek word, okay? Now, here, that's how, so your complex number contains, I already told you, it contains both real number and imaginary number, right? So, real number, I am naming it as A, and imaginary number, I am naming it as IB. Okay, so IB is basically your imaginary number. So A is your real part, IB is your imaginary part. IB is your this one. So the whole thing, when you take, that will be your complex number. Okay, so that will be your complex number. So A plus IB will be your complex number. Okay, so just keep this as such. So let me give you few examples of a complex number. So when you take an example of a complex number, you can have Z is equal to 3 plus 4i. So here, what is my real part? My real part is this one. Okay, so this is my real part. What about my imaginary part? So this is my imaginary part. Okay, so basically this is my real part and this is my imaginary part. Okay, so and what about others? Won't you get in any root? You can definitely get I in roots. So you can definitely get imaginary number in roots also. Like you can have root 3i. So for example, it is minus root 3. You can write as minus 1 into minus root 3. You can split it and write it. So it is nothing but root 3i. So your complex can have any number, any, I already told you, it can have any number, which is a combination of real and imaginary. So what about this? So when you talk about 3, is it a complex number? Is it a complex number? So when you talk about 3, is it a complex number? Yes. I already told you any real number is a complex number because your complex number is a superset. So any real number, take any real number, it is a complex number. Tell me how. See, you can write this Z is equal to 3 as 3 plus 0 into I. 0 into any number is 0. So basically, your imaginary part is 0 into I and your real part is 3. So any real number can be expressed as an imaginary number. Okay, that is our conclusion from this. So what can you say? Any real number can be expressed as a real imaginary number. Okay, so let's check. How can you express the imaginary number? Okay, so for example, I'm taking the number as 11. Okay, be it minus 11. Okay, so Z is equal to minus 11 I'm taking. Can I express this number as an imaginary number? Yes, definitely you can, definitely you can answer, like you can change this real number into a complex number. How can you change it? It is minus 11 plus 0 into I. Okay. So how can you change it? This is basically minus 11 into 11 plus 0 into I. So my conclusion for this, any real number can be expressed as, any real numbers can be expressed as complex numbers. Okay. So any real numbers can be expressed as complex numbers. So this is our important note which you have to see. Now let's quickly come to our powers of I. So powers of I, let's see. So if I power 0 is that, anything power 0 is nothing but 1. So I power 1. So I power, anything power 1 is the same number which is I. Okay. Now I, imaginary of powers of I, no? So I square. So what is I? What is I? You know I is nothing but root of minus 1 which is I only. Basically root of minus 1 which is I only. So what is this? This can be written as root of minus 1 the whole square. So root of minus 1 the whole square is basically minus 1. So this is my root of minus 1 the whole square. Now what is I cube? I cube, how can I split it? I can split it as I square into I. So it is I square into I. That will be my I cube, right? So what is my I square? Just now I saw that is minus 1 into I, which is basically minus I. So what about I power 4? I power 4 is nothing but I square into I square, which is basically minus 1 into minus 1, which is nothing but 1. Okay, so I square into I square. So you can split, right? Basically, how can you write it? 4, you can split it as 2 plus 2. That's how I split it. Okay. Now, what happens in the next one? I power 5. How can I split that 5? So, I can split in terms of I power 4 into I. So, basically, what is I power 4? Which is 1 into I, which is again I. Okay. Now, let's go to the next one. What about I power 6? So I power 6, again I'm expressing in terms of 4, I power 4, because I know my I power 4 is 1. So I'm using it. Okay. So basically it is I power 4 into I square. So what is I power 4? Which is 1. What is I square? I square is minus 1. So my I power 6 is again minus 1. Okay. Now, what about I power 7? So, I power 7 is nothing but I power 4 into I cube. So, basically, it is nothing but 1 into, what is my I cube? My I cube is minus I. So, further if I do, what will be my answer? So, it will be minus I. So what about I power 8? I power 8 is I power 4 into I power 4. So how can I write 1 into 1, which is again 1. So how can you see your I power 0, your I power 4 and your I power 8 is 1. So you have a sequence, right? So when you look into the answers, all the powers, when you look into it, you can definitely identify that you have some sequence in this power, right? Can you see some sequence in the power? Yes, right? So that is what is actually that is what you will be actually finding. So basically you'll be having I power 1 will be equal to I power 5. That will be equal to I power 9. That will be equal to I power 13. It goes. So this will be equal to I. Okay. Same way, I square, I power 6, I power 10, I power 14 up to it goes to minus 1. Okay. Same way, I power 3, I power 7, I power 11, I power 15, it will go to minus I. Okay. Same way, I power 4, that will go to I power 8, I power 12, I power 16. So it goes to 1. So all these terms, this is a separate thing. So this, I told you, you have a sequence. When you see it, you will definitely have a sequence, right? So you will definitely have a sequence, right? So that is how I have written it. So you have a sequence. Can I form it into a normal conclusion? Can I generalize it and give it to you so that it will be very easy, no? When I generalize it and when I give it to you, what is my answer? So basically, what will it be? So when I see I, it is basically 4k plus 1. Basically, your I will be 4n plus 1. That will be equal to your I. So be it, your I can be 0. Your n starts from 0. So when it is I power, when n is equal to 0, it will be I power 1. So basically it's I. When n is equal to 2, it will be, when n is equal to 1, it will be 4 plus 1, which is 5. So basically this is our conclusion. Similarly, when I generalize the second equation, when I generalize this equation, what do I get? I get 4n plus 2 is equal to minus 1. And when I generalize the third equation, 4n plus 3 is equal to minus I. And when I generalize the fourth equation, it will be 4n is equal to 1. So this is your generalized form of power of I. Generalized form to find power of I. So this is your generalized form to find power of I. Okay. So let's solve a quick question with this. Okay. So if I ask you to find a power of I power 44. So first what you should do, first I'm checking if 44 is divided by 4. So 44, 4 is 11s are, and your remainder is 0. So how can I express this? It is 4 into 11 plus 0. So basically it's nothing but I power 4 into 11. So it is of the form I power 4n. What is I power 4n? That will be equal to 1. So your answer will be equal to 1. Okay. So this will be your answer. So what about I power 70? So now again I will check and I'll divide and check. So basically if I divide and check 70, it will be what? So what will it be? It will be true, or like 4 times if you do. What will you get? So it will be 1s are 4, 3 and 7s are 28. So you'll have a remainder 2. So you will definitely have a remainder as 2, no? So this will be what? So this will be I into 4 into 17 plus 2. So this is of the form I power 4n plus 2. What is I power 4n plus 2? That is minus 1. Okay. So you'll be having minus 1. So this answer is minus 1. So did you guys understand it? Yes. Did you guys understand it? Okay. So now let's quickly go, let's quickly check for the some other things. So for example, if I give you I power 56. So how will you do? Again, you have to divide it by 56. So 56, 4. So it is 1s are 4 and again you will get 16. So it is 14. So 16s it will go, no? So what can you conclude? You can conclude it as 4 into 14 plus 0. So again it is of the form 4I power n, right? So again what is of, it is of the form I power n. So I'm not writing n. So this is of the form I power 4n is equal to 0. Like sorry, not equal to 0. I power 4n equal to 1. You know it, right? So this is again of the form I power 4n. So what can I conclude? I can conclude that this is equal to 1. So this is the basic main concept which you have to know. So when it comes to a complex numbers introduction, basically I've taught you only the basic. How did the complex number arrive into the world of number of systems? Then I told you what is the main concept that you should know in the complex number, the main basic, that is imaginary number. Then I told you what is a complex number. It is a combination of both real number and an imaginary number. Then again, every number has powers. So what about iota? If iota has powers, you will have something like this. So you instead of finding continuously, I have generalized and given this equation. So yes, that's all for today's class. In next video, we'll quickly solve a lot of sums regarding this. Until then, it's bye from Harismita. Thank you and have a great